I'm Daniel. I will be doing a series of hooting tutorials showing some techniques that I've learned doing film and personal projects. And for this one, I would like to show you some ways to add nice breakup and detail to the emitter of fire and smoke. As we can see in this reference from the Facebook effects references, I like this fire because there is some nice shapes here, some nice details in the emitter. You can see here small flames, and here bigger flames. There is areas where there is like negative space where we have big flames here, almost no flame here, or very small, and then bigger here. So we will see how we can do that just in the emitter, which will help a lot. So to start, we can start with a grid. Then we will see the same technique applied in different objects, but just to start, and it's more simple, we can do it with a grid. So we'll have a grid here, then we'll just scatter some points. We don't need to relax, normally this makes it very slow. So we'll add some points. Can have round number. It's easier to add just one more zero. Or maybe not, maybe adding half number, stuff like that. So then to start we will do sphere, because we want to define, so we want to add some, we will use the polygons of the sphere to add the breakup around here, because you know, you can do, you could use any shape here to meet from. Normally modeling will give you, or environment, you will get geometry from them, and you know, you will have to pick some parts here from where you want to emit from, you know, do it somewhere, something like that. Then you will want to, you know, have some more resolution here, add some noises, stuff like that. So it starts to get complicated if you want to add some nice detail from here based on your geometry, and you never know the resolution of your input geometry. So it's better if we play with this. So that's why I have the scatter, and then we'll have a sphere here with some polygons that we can add noise on. So then we will have, I added lots of polygons, maybe too much, just to see at the beginning. So now I will call this position noise, and from here we will just, as the name says, we will just add a noise to the position. Using the position from the source, we'll add the position from the turbulence, classical. So, and this, we will use this to make a group from this, and then we can use it to define the breakup. So we'll very easily rename this to delete, or just to deal, and then we will use the bounding box region, bounding object actually. So now we're defining the breakup of the object. With this we can just promote the parameters so we can have more control and be fast here. And then we will just remove what's outside of this group. And now we start to have some breakup here. So you know, there's easy ways to control this, which is the radius of the sphere. So you can control how much fire you want around this, and then with this you can control very easily how much breakup you want to have, and you will want to have a lot of it. So we want to increase this, we want to break, it doesn't matter the shape of the sphere, as long as we have good shapes here with the points. So maybe I went too crazy, but that's why you will want to have some nice resolution here, so you don't want to see flat parts where you're cutting. So maybe you want to increase this a bit, or play a bit with with the parameters of the noise. So maybe we want something like that. So this is something, this can work. I think this, this can work as well. There is some nice breakup here, but I would like to do something more like a bit more focused, something like that. To add a bit more breakup, we can also add an additional position noise after we have everything together here. So with a very small amplitude, higher frequency. This will add a bit more breakup here. If we still have some straight flat edges, we'll break up a bit more. We'll also add extra layer of depth here, because we can animate this. We should animate the offset Y, and we will see some movement here, so this will help as well. Maybe we can increase this amplitude a bit more. So yeah, something like that, maybe decreasing a bit, something like that. If you don't need the if you don't need the motion here like this, you can always project it back to the original geometry like this. So then we will just use minimum distance. So now we added some noise, but we still keep the original shape. Continuing on, we can add some additional fires, smaller flames, as we talk about, around the main source, because here we only see a big, just a big core, but it always helps to add some smaller parts around it. So to do this, I will get the centroid of this sphere, and get the point here, and now we'll replicate this point with as many smaller parts as you want. Maybe you probably don't want that many, and then it's good to do maybe a sphere, play with it. Obviously this will be three-dimensional, but again we can move it back to the original shape. So now we have it two-dimensional, or whatever the shape is, just based on minimum distance. Now what we can do is to add more points based on these source points with another point replicate. So we'll see this, and now we can add way more points here based on this density. So we want similar density of points, something like that. Always the sphere look works. Smaller scale, and again we want to radius, so we don't lose our original emitter shape. And now if we increase the radius of the first replicate, we start to see how this behaves. So now we have some breakup at the borders, like we have some smaller flames, and obviously the more you want to add here, you will have more shapes and more complexity to it. Obviously now everything looks the same. To improve this, we can include this inside of for each point here, so we can do that. And then what we can do is we can just play with this uniform scale here. We can do, we'll have a detail expression based on the iteration number, so I like to call it data, and now we can reference it here, and we will do detail data, and then we can iteration and 0. Oops. And what we want to do with this is fit it to our range. So 1, 0, we'll play with that, but this may work. So let's see what happens. This one is quite small. Then it's all together. Let's see. Let's see if this one is bigger. Iteration. Something is going on. So what I forgot here is to add the random expression as well. I think we'll go here. So we want the random of the iteration. We want to fit this between whatever number we have here. So now, as you can see, we have some randomness here. You know, this is too much. We can always promote those parameters or something to play more with them. Now we have different shapes. Decrease this a bit more. This is too much overall. Something like that should work. And then we can add a bit more noise here. We can also add some variation in this based on the iteration on this noise. So it will always help with the breakup and randomness of it. For example, we'll do that. Play with more with this. And then after this for each, we'll array again. So now it fits to the original limiter, and now we can merge all together. So now we have this one and this one. So now, as you can see, we have the main core of the fire, and then we will have the smaller ones, which will help to add some breakup as we saw in the reference. Normally that looks always more natural to have a bigger core and additional smaller fires around it. It always helps. To continue with this breakup, we will add some negative space to it. We will delete some points from here with the noise as well. And to do this, we will do a noise color, classical way as well. So we will do using the position color. So now we have some. We should see some noise here, as you can see. So we can add some breakup. I mean some frequency, and now it's good to promote these parameters because we will add more than one. And then after this, we can delete by color. If color red it's smaller one than 0.2, for example, we'll remove point. So with this very simple code, we delete based on the color. And then what I will do with this is I will do a small OTL or something. Delete by noise. So this is very helpful because once we have this power list into your ODL, for example, it will be very easy to just do another one, play with the frequencies. So now you have more breakups with different scales. So this will always help as well. And after this, we can start adding the attributes. So actually, noise. This one we can add the burn. No, sorry, it's not here. Attributes, burn, and temperature are the ones that we want. We don't need to see the color here. But what you can do here is to, once you've done with this, you can delete the color here because we don't want to see it all the line through the setup. So it's good to delete here, and now we have clean points. And to visualize, now we want to visualize these ones. So we'll go back here, visualize one of them. Doesn't matter for now. We need them one-dimensional. And and now it's just a matter to play with this. I've seen the new shelf tool is using one of these noises. I think it's cool. They look nice, so we can just play with them. One of those, and then yeah, basically with this. Also, once we have this, what I like to do to add the taller flames and smaller flames, even more breakup to it and more control, we can scatter some points to the original geometry again. I will add another point here just because we're doing this several times. Now we have it more clear. This one as well. So now everything comes from here. So these have a bit more points. And then let's see. Then we will add this attribute mode. Attribute equals, here will be 1. And then here what we can do is we'll do 2. And then we'll transfer it from those points to here. And then it's good to do, after this we'll do was it the burn? Yeah. Burn and temperature. We'll do, oops. Burn will be plus equal attribute mode. So this should work, hopefully. If we, this one should be 2. Just to see that it works, we can increase this a lot, and then we can increase this. We should add which attribute we want here. Attribute mode. We can just do the smooth one, and then it's probably the opposite. What happened is that I had this very high, so we couldn't see the range of it. So this has to be not too high in order to see it very well. So and we have to have it selected. Okay. So now we can see how the burn works. The range changed because it's adapting to visualization. I think this is too high, so it has to be 1 and 2 will work. You see now it's more smooth. So that's the burn before and that's after. So you see now there is more. So this looks, there is less, but it's just visualization. Here there is just, when it's more white, it's actually just double as before in a smooth way. So this will help. And then yeah, we should not put too many points here. Maybe have, yeah, this looks good. So something that also works is to use the same source point from here and do basically exactly the same that we did here. So we can just duplicate this. Actually, it's better to do it before. It doesn't really matter, but we just, because I want to decrease, I want to multiply here by half and this one by 1.5, so it just a bit. What I want to do, I want to get this point from here in the original. So basically this is the point that we use from the sphere that we use to scatter those points from. So I'm using this same point to just multiply the burn by and temperature by 1.5 in the core, and then slowly decreasing towards 0.5 in the edges. So what I want to do, the edges will be, the flame will be smaller basically. So with this we can try to visualize it. It's easier if you visualize just the attribute mode. So now we can see what we want to do. So I want to be the flame bigger here in the core, so we'll have something like that, just by a small amount, you know, just multiplying it, maybe half as too much, but you know, just matter of playing with this. So And then yeah, we'll just burn. Don't forget also to add the temperature or whatever, all the attributes you have here. Temperature, the same here. Now we just have to add this one goes first, so we'll do this one here. We'll put this one down to organize, and that should be good for now. I will organize this a bit more, a bit better, so it's more clear. So this will be the core of the points. So space, for example, and this will be the smaller source. Source smaller, for example. So this is the smaller source. This is the main source. All together. Here we can have some. Oops. Here we can add like whatever negative space. It's always good to add these boxes to organize it. You want to have it as clean as possible, and this one will be the, even here or here. This will be the attribute breakup, or attribute masks. Maybe it's better, masks, attribute masks. So yeah, and then from this you can do an OTL, from all of this. So now we have that's the output, and then I will do an OTL from this. Just that. Well, now it's just a box, a subnetwork, but it will be useful to just promote all the parameters and do all of this. It's good to add an output here. And then, the good thing about this is that now we can just basically change the input, and we should have something that works in a similar way. Obviously the radius of the sphere, it's too big now, but either we decrease that just to show you, or we make this bigger. Actually we can do it here. So now we can see how this works. We have this bigger fire here, and we have a smooth breakup edge. Now, in this case we have these points here that we don't like, and we can always delete them afterwards, but we already get a very nice first step for the fire emitter. Something additionally that we can add to this is velocity. So if we go inside again, we can go here after this attribute noise. We can make some space here, and then we can add another attribute noise, and we will make it velocity, and then we will visualize the velocity. We need this to be, we will make it a bit, we'll remap it because we need it from -1 to 1, and then we just play with the size, something like that maybe. And then we don't need to increase this. We will increase it on the emitter of the volume. So this should be good for now. Yeah, what we can do is we can make add some expression here. For example, frame divided by 5. So we have it has some velocity. So it's not the same. We can do the same for the temperature, so it's not always the same value. So now it's static, we can do the same here. So now if we put this expression in the offset y, we'll have some motion. So this should add more variation to the emitter. And then to see what we're doing, we can start adding the fire. So we'll do a rasterize attributes, and we can do I think it's the burn and temperature and velocity. This can be smaller so we can see it better. Maybe this even smaller as well, similar size. This should be good. And then I will be using the new Pyro solver. I think it's faster, very simple to set up. The source will have these things. I won't be using the density, and I like to set this to add because I feel I have more control. This should be okay. We can play with this to make more noise in the source velocity that we added before. And for now, this should be alright. We can do here. I'm just matching a bit the settings from the shelf tool, which has a nice start for this one here. So I'm doing something similar. And this can be a bit smaller. And then we can use the turbulence from here, or we can add our own. I will add this raining. This can be faster and have more octaves. So let's see what we get with this. Maybe we need to have a bit more resolution. Not too crazy because we still want it to be fast. And then what we can do, let's see if it works on the look. We can see if we want it more, no, maybe we want the fire to be more intense. Maybe this can be a bit higher. So we are isolating more the flames. This doesn't need to be, like for example, if we go further away. So we are getting rid of the, let's say, smaller density, and we keep the higher density flames. So it should get more detail with this as well. So additionally, we can add the turbulence and disturbance, but to do this, I think it's better to do it inside the solver with this forces subnet. It just goes into the forces of the solver. So I think this is more clean. So we just want to add some turbulences here, and we can have few of them with different sizes. Maybe pulse length I will always quick, and for the density field we'll use the temperature, and then we'll just merge it here. And the reason why I want to add a few of them is because we will use different sizes. So this one will be, it can be 0.5, and this one will be quite smaller, 2.1. Scale the smaller one, maybe bigger. And then we'll do the same for the instruments. This is too strong, but I will be using the block based. I think this has more control for the size. The way I understand, I think this is different from the previous version. But I will stick to block base because I can touch this. So that 0.2, and we'll do the third one will be 0.1. Everything else should be okay. So we want to match those three, and we'll see what we're getting now. I will do flip book. So as we can see now, the fire, it's very crazy, and because we have lots of forces and things going on, I will try to add a bit of substeps to see if this helps, and to see the difference I will save this one, and then here on the sequence list we can compare with the other ones. So that's the new one, and we can see that it's a bit more smooth, the shapes of it. That's the old one, and you can see it's a bit more crazy, more noisy. So we will stick to these 3 substeps. And I think we're getting some interesting variation here, but the resolution is still too high, so, well, it's low, so maybe we don't see enough what's going on. We can try to increase this a bit more to see a bit more clear. Something that we've seen we can change is this we can set this to single project. This is also a new feature, and I think it just, as it says here, if you read this, it just helps a bit more with the, to add some maybe, to add a bit more of vortex, so will help with the details of the fire, hopefully. I will do a new flipbook. So now if we compare this to the previous one, we can see we already have more life and more resolution. So that's the new one, that's the previous one. We have, I think, better behavior overall. And then just to continue, we can go back to the grid. We'll see better what we're doing here. We don't need to see that. In template, we can merge together. We'll have better visualization. Get rid of that. So now we're back to the grid. I think something to tweak a bit will be the masks that we did before. So this first mask that we have this gradient, I think the gradient is too strong. I think we can set this to 75 instead of 0.5, and this maybe can stick to 1 or something like this, so we don't have that much of a difference. This one's 2, maybe we can make it more, this one we can make it more like stronger. That's the one that is coming from the points. This one here, and then maybe we can make this a bit smoother. And then this we'll see more what we're doing. We'll see more the effect of it. I will do a new flipbook of this. So that's the new sim on the grid. We can see a bit more the effect of it. We can see more the peaks of the temperature based on our masks that we have. We can see it's stronger on the core and softer on the edges. And now if we compare it with our reference again, we can see in terms of behavior we're getting close to it. In terms of overall shapes, obviously in terms of detail there is still improvements to do. Maybe our bigger turbulence is too quick, the pulse length, so maybe I can do this now. And then let's see, no, it's actually inside. That's the bigger one. We can do this a bit slower, maybe decrease this a tiny bit. And then something else that we should try is, we can see something that is here is obvious and we don't have, is that here we have something that is burning. We have the ground is not flat. Our case we're just emitting from the ground, So here, just the fact that you are emitting from a surface that has lots of noise and lots of shapes, it already gives an additional layer of breakup and details. So we should try to do something similar. And for this, we shall go inside. We can do it here, for example, or after here. What I would like to do is, in this case, I would like to get some of those points, just very few of them. I like to set this number very high. The higher this number is, then the more precise you can be with the points. If you have lots of points, you will have to increase this number. This should be good, and then we can have is an attribute noise again, or randomize. attribute randomize, we can set here the p-scale. I like to set it to ramp. And with this we can do the classical exponential thing with the ramp, and then we can just fit the values. So we'll see this better if we copy the points. In this case we can have a sphere, just to see quickly how the attributes work. Set this to polygon mesh. So now we can just copy this. We can see how our attributes behave. So p-scale same is there. Maybe this can be smaller, something like that. And then we also have to do the same for the orient. This time it's 4-dimensional, and we can do 2 values, and I think this one has to be -1. Right. It's better with uniform. So now we have random orientation, and then maybe we either add more points or we can make them a bit bigger, the smaller ones. And this, then we can scatter on those things again. And once again, we will need a similar point density as we have in our setup. I will just make a bit more space here. So this will go after. So this we will have here. And this will merge to our pasting. So that's even more points. So, you know, you can do it both ways. You can either not use any of this and use only these points to emit from. I think it's always nice to have something everywhere, and then you add this on top to add just more noise and more breakup on the profile of the emitter. So then if we go back to the end, you can see what we have. Maybe we can add a bit more density to these points here. It's only affecting these ones. Something like that maybe. So this will already give us more life to the fire. Something what we can do to see how it's affecting. We can output the geometry, and then we can sit here as well on the merge. So now we can see everything together. I will do a new flipbook of this. So with this setup of the additional geometry, we can see how we added an additional dimension into the fire in terms of shapes. But this rocks was just a reference for the attributes to see how it works. But I think to make it cooler, we have to add something that has more shapes, or like something that is cutting the fire in bigger terms. So we can try to do this is, I will use some of the assets of Megascan. So I have bridge here, and I will just be loading the Megascan's lifelink, and then it's very cool because we just one button, we get these plans here, but I just want to use one of them. So I can go here, I will just copy this node, and I will go inside here, I will object merge that object. Hopefully this works, yeah. So I will just put it here. This is just as an example of what we can do in terms of shapes. This can be way bigger. Maybe we just want very few of them that are big. Small ones can be bigger, something like that. So So we can break it quite a lot. So let's see what we have now. I think we have to add more points because this has more, has bigger density, has bigger mesh. Okay. So now we have way more points that we can play with. Maybe we went too far with this, maybe we can just have a bit less points. We should add another 0 here. Now we are copying too much. I have one more 9 because we had too many copies of this. So maybe we want a bit more. We'll be decreasing this. Do something like this. This is maybe works as an example. Maybe we can change the, we should change the seed here, just to see different options for the distribution of the scale. I think something like this works as an example. So if we now go back to our simulation and we make a simulation of this, and we'll do a new flipbook. We'll save this one and I will do a new one. So that's the flipbook. I think we are too close from it to see the whole picture, so I will do another one that is a bit farther away. Something like this, maybe we'll see it better. So that's the simulation from a better view. And in order to appreciate all the efforts we did to add some more, to add all the breakups here, I think we can decrease a bit the temperature in the source. We can actually link these together because I find that it works better when it's together. So we can just add a bit less. We'll see what we will see what we get in the new flipbook. So we can see how this flipbook works better compared to the previous sim. We had lots of temperature and now it's more localized. We can see more the negative space and all the effort we did. So obviously this scatter geometry will depend on your scene. If you have a forest, you will want to scatter branches. For instance, you will want to scatter with something like this, with different noises, and then in a different environment. Maybe you will want to scatter some assets like this or things like those, something that makes sense and that adds lots of breakup into the shapes. Now we can try to see what happens if we just go back and change again our rubber toy. So we can see that everything holds up. We just change it, and this obviously the orientation is too strong, but maybe we can just go and change it a bit. Maybe we can just change again maybe we can change the seat of the orient. So this maybe is doing something. So as you can see, in this case maybe the example doesn't work very well because this is already a geometry that has an outline and has some shapes to break it. Before we had just a flat ground, and makes more sense to have some more scattered objects into it. But if you have the geometry, maybe it doesn't make that much sense, or maybe you can have it smaller, or maybe it still looks cool. I will do a flipbook of this and we can see it. Actually, I will make the scatter geometry a bit dark so we can simulate what we will have in a shader, because normally it's this geometry. Normally what I think it's this geometry here. So Normally what I will add is like a dark shader or something like this to simulate that is burning. I think we can just change this one for this one. So now I will do the flipbook now. So that's how it looks on the rubber toy with the dark shader here. I think again we have too much fire for what I wanted to do. I wanted to have some more details and I want it to be more tiny, so I will do another one. I will cancel this one. I think we can just do it here. Maybe we can just do 1.5. It will look quite different. So let's do another one of these heights all the time. Okay, so new one. So that's the new flipbook. We can see already that it's more elegant on the fire. It depends on if you want more or less. I think the setup we did, it's more visible when the surface is flat. We can see the variance a little bit more. But obviously, if we had all the rubber toy on fire, we will see better differences and different shapes and negative spaces. But the technique will be exactly the same. So I hope you find it useful. This tutorial was just about more about the emitter than the fire itself. Obviously, we will need another tutorial just to finish it and make a shader and render it and all of this. But I think having a good emitter is very important. It gives you already 90% or 80% of the job. So that's it. I hope you find it useful and thanks for watching.